All right, now on to number 17, test 2, section 3. So what you'll notice on this one is you're going to have, and this is something I've seen a few times on the SATs, where they have an equation that, they have kind of in a different form, set equal to, say, a standard form equation, or maybe a factored form equation, or whatever the case may be. But our goal on these types of problems here is to get the form on this side into this form. So that means I need to multiply everything out. So we're going to multiply everything out here. Once we do that, hopefully it'll, obviously not hopefully, it will be in this form. So I'll know what A, B, and C are. Now this one, they want us to find the value of B, but again, it doesn't matter. I'll have all of them. So that just means I'm going to start multiplying. Distributive property here. So I'm going to multiply 2x across. So it's going to be 6x squared plus 10x. And then I have the plus 3 here. I'm going to multiply that. So that's plus 9x plus 15. And again, I'm only really concerned with b, but I'm going to go ahead and put it in standard form anyway. So that just means I'm going to combine these like terms. So that's 6x squared plus 19x plus 15. Now again, they just want to know what b is. That's the term in front of x. So this is my b value, which is 19. That's what you'll plug in for your grid-in answer for number 17. Moving on, number 18 has this picture. Now before I do anything with the problem, as soon as you see this picture, you should be thinking of similar triangles, which means you're thinking of proportions. So I'm going to be setting up a proportion here. I just had to make sure that I set up ratios of corresponding sides. So anyway, with this one, they're going to give me some clues to help me do that. They're going to tell me that A, E, and C, D are parallel. So A, E, and C, D are parallel. And again, it's just some of the stuff that this means. That just means, alternate interior angles, like these angles right here are alternate interior. And again, I'm just using this concept of alternate interior angles. So you've learned about that in geometry. So I have alternate interior here and alternate interior here. Not that that's required or they're testing that here, but it just kind of helps you see that this triangle is flipped. So the 5 on this side corresponds to the 10 on this side. So what they just already, and again, they haven't said they're similar. You just have to kind of figure that out yourself. But I'll tell you this, if there's two triangles that look similar on a test, they're similar. So these are similar, and I can tell that this triangle here is twice as big as this triangle. So I know this 8 goes with CB, which is 4. I can just kind of see that. I don't even need to really set up a proportion here. I can just kind of see that ratio right away. So anyway, in this case, segment AD intersects CE, which I know that. What is the length of CE? So CE is this entire length. So CE, in this case, is going to equal 4 plus 8, which is 12. So I kind of solved that before I even read the question. You just look at the picture and fill in what you can. And I read like one sentence, but that's all you need. So that's going to be number 18. That was quick. So number 19, they're giving us this point radical 3, 1. Now, when you see a radical 3 on the test, I want you to think of 30, 60, 90 triangles. Again, when you see that radical 3, again, why would they have a radical 3 on this test? Well, that's probably why. So the 30, 60, 90 triangle, the rule on this is 30. That's a 3. It just doesn't show up very well. Okay, so that's a 30. That's a 60, and that's a 90. So this would be x square roots of 3, and this is 2x. Now remember, they give this to you on the test. You can just flip the pages and see it. So what I want to do is I want to see, like, okay, where can I put a 30, 60, 90 triangle? Well, where can I put a triangle? And just see if it's a 30, 60, 90 on this one. Well, here's that triangle. I'm going to go right here and draw my triangle. And I can draw it here because they're giving me the side lengths. They're giving me this point, which means to get from this center point to this terminal point, is what it's called, I have to go right radical 3, and I have to go up 1. So if you notice, they just gave me these sides. This problem isn't really asking for it, but if they were, I can find the hypotenuse pretty quickly without having to do Pythagorean theorem, because the side x in this case is 1. So I know that 2x would be 2. So I know that length is 2. But they're not asking for that here. What they're asking for is the angle. They're saying what is they're saying the angle AOB is pi over a radians. So what is the value of A? So we need to know what the radian measure is of this angle right here. Well, I know the degree measure is 30 degrees because, again, I'm able to shove in a 30, 60, 90 triangle because these sides would all kind of match up with that scenario. So once you have all this and you know it's a 30-degree angle, what you can do, first off, if you just know that 30 degrees is equal to pi over 6. Now you'll know that if you are in like a trigonometry course and you've studied unit circle concepts and things like that. You're going to know that 30 degrees is pi over 6. So that's the case. Said pi over a is the angle, so I know that a is equal to 6. If you don't know that, what I'm going to show you real quick is based off the skills you already have. There are conversion formulas that you'll learn in trig that might even do this a little faster, but I'm going to teach this in a way that you've never seen those formulas, because if you've taken a trig class, you're not going to use those formulas I'm talking about anyway. What you do know is you do know how to set up proportions. So I have to kind of relate to you one crucial concept. You have to know that 360 degrees is equal to, and I'm setting this up as a proportion, so these are going to go on bottom, is equal to 2 pi radians. Now that's the one thing you do need to know. 360 and 2 pi are the same thing. So when we're converting to radians, you have to make this connection. So you know at this point 30 degrees, well that's my angle for that pi over a is 30 degrees. I just have to convert it to radians. So I'm going to go 30 degrees over 360. That ratio is equal to this ratio, x over 2 pi. And that's, again, just using conversions like we're used to using conversions. So before I do cross product and solve this, I would cancel out a factor of 10. So that would be 3 over 36. 3 goes into 36 12 times, so I can simplify this all the way down to 1/12. So 1 over 12 equals x over 2 pi. So now I'm going to do cross product. So 12 times x is equal to 1 times 2 pi, so 2 pi. And you divide, you're going to get 2 pi over 12, which is pi over 6. So in the end, like I said, you want to just know the unit circle. That's the easiest way to do some of these. And for the SAT, all you really need to know is this first quadrant, the unit circle. If you know that, you're going to be doing awesome, because they don't really test much past that. But anyway, if you know that 30 degrees is pi over 6, that would have been a lot faster, but you can also do conversions using proportions. You just have to have the degree measure, and you have to know that 360 is equal to 2 pi. So anyway, that's going to be number 19. Next up is number 20. So on number 20, they're giving you a system of equations, but what they're telling you is that they say it has infinitely many solutions. So that's kind of the key on this, because you have two variables, so it's going to be kind of hard to solve for. But if you know there's infinitely many solutions, what they're kind of saying, and I'll just kind of put this, I'll put it down here, you have infinite solutions. What they're really telling you is that these are the same lines. And when you say same lines, you're kind of saying slash equations, because to have the same line, you have to have the same equation. Now, right now, you can kind of see at this point that 12 and 60 aren't the same number, but if I was able to make those the same number, then I would then know what the coefficients are supposed to be. So what you can then do is, so I can just keep a and this the same, you want to figure out how many times does 12 go into 60. So you can figure it out by hand, or you can literally do some division. This would be kind of long because 12 and 6, whatever, but 12 is going to go into 60, in this case 5 times. And again, if you did 12 times 5, it would cancel and all that. Although doing long division is probably not the best way to do it. But anyway, we know that 12 goes into 65 times. So what I'm going to do, I'm going to try to make these numbers the same. So I'm going to take this equation and I'm going to multiply it by 1/5. I'm going to divide everything by 5. So when I do that, this equation is going to become, when you distribute the 1/5, so this is going to be 2 times 1/5, so 2/5 x, plus 8/5 x equals 12. And now that I have both of those numbers the same, I now know what a is. A is 2/5, b is 8/5. So I'm going to come down here, and I know that I know what a and b are right now. Well, they want to find a over b. So if they want a over b, well, I can go ahead and do that for them. A is going to be 2/5, so I'm going to go 2/5 divided by b, which is 8/5. So you divide those, you keep, you change, you flip. So I'm going to keep the first fraction, change the division to multiplication, and flip the second fraction. Here, the 5's cancel. You get 2 over 8, which is 1/4. 1/4 is, it's a grid in, so you just plug in 1/4. So that's going to be your answer for number 20. So that is section 3. That is the last one from section 3 from test number 2.